So today will be various topics on transportation, energy, and climate. Emphasis on climate. The last part will be about renewables, the middle part about the IPCC, and the beginning will be more general on climate and transportation and energy. And I think I already showed this diagram. You must help me, because now I don't remember quite all what I showed. But I think I just showed you that diagram, and then I found here some slides where I very pedagogically drew all the. So this is the total gain, right? If you do something about congestion, and then here is the value that the victims of pollution get, the value of cleaner air. The area between the total marginal cost, including the environmental costs, and the marginal social cost, just including congestion, but not the environment. Here is what the state gains in tax revenue, and that's what the motorists gain in time. So the difference, well, this is what the motorists pay. This is what the, well, there's two categories of motorists, right? These are the motorists at the end of the program, the motorists who continue to drive. And they actually make a loss. They gain time, but they pay tax. The tax has to be bigger. Here are some motorists who stop driving and they lose consumer benefit there. Right. Technology is also very important. Here you can see the emissions of volatile organic compounds, nitrogen oxides, and particulate matter for 3 different categories of car. The diesel engine is the one without the spark plug, and the Otto engine is the engine with the spark plug, usually just called normal motor, right? But these are 2 German engineers, Dr. Otto and Dr. Diesel, some time back. Whichever one of these you take, it doesn't really matter. Take the first 3 up in the left upper corner. You see the emissions were 2.5 in 1988, 0.89 this is per kilometer 8 years later, and 0.08 in 2010. They fall very fast, right? And that's true for all the different emissions in that table. So I have here a very deplorable photo here.
No.
Yeah, I'm hoping for some protest. There was actually, I've lost that. I had a slide where I think Volvo or some other company had an advertisement for like a shine, and so I took a photo of the advertisement, but I don't know where I put that anymore. And it said, "Be a good environmentalist, buy a new car." And I reacted in horror at this advertisement. I just, it's a personal thing. I never really appreciated shiny new cars somehow, and I thought that can't be true. But then, I thought about this, and I can't help but saying that there is some truth to it. But you have an objection.
Driving, but I mean, making the car. I did a quick calculation once, just looking at CO2.
Yeah.
And then that the mean lifetime should be somewhere between 10 to 20 years for a car. If you just look at CO2,
yeah.
And assume a linear drop in emissions. But of course, I mean, we consider all this as well, though. But 10 to 20 years should be a lifetime of car, of course, when it's scrapped.
Yeah.
So I don't know.
Then what?
Then you repay. Then you sort of. That's how often you should switch out your car to get optimal. So
from the viewpoint of
equilibrium, sort of. Let's assume that the CO2 per mileage is dropping just as fast as it's done the last 30 years. and then put up how often should you switch out your car to get some
Right.
optimal.
That's assuming that you throw the car away and that no one else buys it and uses it,
Yeah,
I
that's
suppose.
after 15 years the car should be scrapped.
Yeah.
So I don't know.
Yeah. So, well, this is for local pollutants, right? But yeah, we're really, climate is somehow for most of us the most important. So, from that viewpoint, it's not quite true. But this is also pretty important. Actually, I mean, in places like Gothenburg, not anymore so important because most of the cars are kind of new, and the local emissions aren't quite so important anymore. But some cities with very old cars, this is quite an important and high levels of local pollution. Sometimes there are some other little. Well, that's another. Okay, same thing. Here, sometimes there are technical details, like the temperature. It makes a big difference. So, if you look at the second row, and the temperature is -7 degrees outdoors, like, I was going to say like now, but it isn't now, but like a month ago or something. Then the first kilometer you drive, you emit 123 grams of carbon monoxide. And then when the engine is warm, which I think actually takes a little bit more than 1 kilometer, but then you will emit 0.8. So the first kilometer is more than 150 kilometers later, or equivalent. That's quite dramatic. What's the conclusion of that? Never drive the first kilometer, right? Well, you could say taxis are better than private cars.
Taxis? Yeah, it sounds like taxis.
Yes. Well, I think that too, of course. Yeah. Well, another conclusion that we kind of do up in these Arctic regions up here is that you can preheat your engine. So you can have an electric heater for the engine. Some people do that. And then you never have the first kilometer effectively, kind of. I think I kind of improvised and talked about this on the board, yeah. In a way, you're right. I mean, you could say that or you could have a congestion charge that depends on the age of the car, right? Which is what I have here. I think the charge should be some function of your vehicle characteristics, where you are, where the car is, that is, the time of day, if it's rush hour or not. Maybe also the weather. You know, sometimes we have something called inversion, and then there is no movement of the air. So the pollutants accumulate more. And in some cases it gets so bad that they actually prohibit cars. Now, prohibiting cars is really dramatic, because I mean, sometimes it's very important to get somewhere quickly, and so that's kind of, but you could have a higher charge. So you could have a taximeter in every car, not just in the taxis, and then you would pay something like this. And I calculated what at some point you'd have what an old car would pay, just assuming some values for nitrogen and NOx and volatile organic compounds and stuff, and using all those figures I just showed, you could calculate what a 1988 car should pay if it's in the countryside, or what it should pay if it's in the city center, and the same figures for a newer car. Right? And it makes a big difference, both if you're in the countryside or in the center of the town, and if you have an old car or a new car. And what you should really do is avoid really old cars in the center of the city. And in fact, in Gothenburg, you're not allowed to drive an old truck, and that is the commercial vehicles. There is a restriction. So, this is the center of London. The thing about London is that even the center is quite big. This is a study by Gunnar Eskelund, one of the first studies, and was supposed to show, I think, you see these steps? They are different measures that you can undertake to make the air cleaner in Mexico City. So, I don't know, one of the first down at the bottom is retrofitting old buses with natural gas and LPG. That's quite a popular thing. They've done that in Delhi. They've done it in Kathmandu, I think. And they require you to have LPG on commercial vehicles and taxis that operate in the center of the town. And then you have other, inspection and maintenance and replacing taxis and emission standards and fuel improvements and things. And there's two curves there. One is the welfare cost, if you do just the measures as they are, and the other is the welfare cost if you do two things. You do all those different measures, but you also have a tax on fuel, and you use the tax on fuel to sort of subsidize some of the costs of other activities. Then that makes it cheaper, economically cheaper combination of emission reductions, because with a tax you also automatically reduce traffic a little bit, and then you're using the money to fund some of the other activities. So that's the point of that one. You can see Singapore's pricing scheme. Well, they have some time differentiated entry. So they differentiate by time. That's because of the congestion, of course. But they don't differentiate by if there's like inversion, for instance. Technically, that wouldn't be very difficult to do, I don't think. I think you could have a radio signal that just says that now there is inversion, and that would, the car would respond to that. It wouldn't be very difficult. Curitiba. How many of you have heard of Curitiba? Or know where it is? Yeah, the Latin American. Anybody else? So it's world famous in Latin America, at least, and in Gothenburg. It's world famous because Volvo has been collaborating with this city, and it's a city in Brazil where they have these fantastic, you see like the left upper photo, they have monstrous buses. They're very big and long, and they have their own road. So their roads in Curitiba, they have the central road is just for the fast buses, and then they have for slower buses, and they have for cars. And so they have quite broad streets, and when you prepay, so you pay for the bus in a machine, and this little but they have provided some shade there, this round thing, so you can sort of, when you get and wait for the bus, you prepay your ticket. This is not obvious like in Brazil. Normally people stand and talk to the driver or something and buy their tickets and waste time. so here you prepay your ticket, and then the bus has big doors on both sides. So when the bus arrives, doors on one side, people get off, doors on the other side, people get on, and like you can load in and load off hundreds of people in like 1 minute. And they've all paid their ticket already, and it's a bit more like a metro. And the thing is that it kind of replaces the metro, but it has like 3% of the cost or something, because you don't have to dig up the whole city and build these expensive railway lines and stuff. So the thing it does require is space. So you kind of have to think about this idea before the city is built. It's difficult otherwise because of big, broad streets. And so the special thing about Curitiba is they had the same mayor for 30 years, and he's been interested in city planning and traffic stuff. So he kind of thought of this. And then Volvo provided the buses. The photo to the right, you got London and my school underwater. I rather look forward to this particular aspect of London being drowned, which otherwise is a sad thing, of course. I thought I'd speak a bit about fuel taxes. Fuel taxes is quite a controversial subject. In Nigeria, they abolished fuel subsidies. Now again, I don't quite remember, did I tell you about that at any point? Did I say what the president of Nigeria, what he's called? Does anybody know? Good Luck, yeah. It's fantastic, his name is Good Luck. He really needs it, right? Because in the north of the country there's an insurrection, a sort of militant Islamistic group called the Boko Haram have occupied quite a large part of the country. When he abolished the fuel subsidies then he had also an insurrection in the south of the country, in all the major cities. There were protests. 31 people were killed within just a few days. And I guess I should feel partly responsible because I'm one of the people who has been suggesting that it's a good idea to get rid of subsidies and tax fuel instead. And so one sees that this is no easy path. Let's come back to that in a moment. Let me just lecture about climate change for a moment. And we'll come back to Nigeria, right? In a bit. Have you seen this diagram before? Well, I know some of you have. Question is there someone who hasn't seen it before? This is carbon dioxide emission content of the atmosphere, right? And the periods when it's been low is when we had ice ages. And just where we're sitting here, there were about 3 kilometers of ice. That would be really bad for this piece of property, right? 3 kilometers of ice. When you fly home, think of that. Look out the window and think about a third of that distance down to the from the plane down to, it was ice. I don't know. I still feel helplessly impressed by this. I think it's quite an incredible fact. And as you know, we won't have any local problem here with sea level rise just around Gothenburg, because land is also rising here. The land is rising. Why do we have land rise? Yeah, the ice weighed so much. When you press something down and then you take away the weight, it kind of bounces back. That is still happening. How many years ago was this? 10,000 or something. 10,000 years later, we are rebounding about a millimeter. Is it a millimeter per year or something? That's also quite fascinating. You see, see what happens when I made the slide first in 2003? I get pretty out of date, right? That's a difference of 25. Just because I was lazy, didn't update my slides. It's quite incredible. 23 out of something that is supposed to be between 200 and 280. I mean, for the last 800,000 years, it's been in that tiny range of 80. And now just 23 happens whilst I'm not updating my slides. I mean, that's this is actually going quite fast. In your lifetime, which is roughly the time I've been talking about climate change, there has been an increase of 50. Now, there have been increases of 50 before, but that typically took 1,000 years or something. So the trouble is when this happens fast. This is how fast it's happening. We actually hit 400. We hit 400 last year, but then it went down again. Why did that happen? Yeah, there's winter and summer variations, right? Because when, let's see, so in the winter, matter decays and we emit more, and in the spring and summer, we suck up carbon dioxide from the atmosphere, and then it's the other way around on the southern half of the planet. But the northern part has more land, and so anyway, so all this creates a little variation there. Now, we have these ice sheets. So sea level will rise. You could do this, Eric. He does this better. Sea level will rise partly because the water just gets warmer, and when it gets warmer, it expands, right? That's the part that is easiest to calculate, because we know that process. We know how much water there is and how much is rising in temperature and how much it will expand. That's kind of fairly easy compared to calculating the ice. If the ice that is on the North Pole melts, nothing happens to the sea level rise. It's still a very dramatic change. But nothing happens because it's already in the water. But if this water on the South Pole and on Greenland, if that ice melts or falls into the water, then we get dramatic changes, which you see. The worst is the East Antarctic ice sheet. That would be a total of 52 meters. So there's a lot of ice there. Big mountains of ice. And we don't know when that will happen, but it will if we continue to warm.
About the glaciers.
Yeah. What should I say about the glaciers? Will they make a difference to the sea level rise?
A few meters.
Really?
Yeah.
We have some big glaciers then.
Many.
Many. So, in case we would have 2 degrees, I must change this. This is old, and I have new diagrams now. But in case we get 2, just make one point here. If we get 2 degrees warming, which at this point in time, we'd be very lucky if we get only 2 degrees. Or lucky, you guys have to work very hard. We all have to work very hard if we're gonna stop at 2 degrees, right? But 2 degrees, that's the average over the whole of the Earth's surface, right? That includes the seas, and the North Pole and the South Pole and land and so on. And it's not going to be evenly spread, and it's going to be less over the sea, basically, and more over land. So it would typically be more. You could look at Africa there, that's somewhere between 3 and 10. Some areas between 5 and 10, and some between 3 and 5. Now 2 degrees doesn't mean, that doesn't sound too much, but Africa, most places already kind of warm. Another 5 degrees. Look at India, between 5 and 10 degrees. There's a lot of people there, and it's already hot. I don't understand another 5 to 10 degrees. There's no doubt that is a serious problem. Will also change water patterns. All kinds of other things will be happening at the same time. Bangladesh will become smaller. as the area around Calcutta of what's it called, West Bengal, isn't it called? Yeah. And of course, other places, lots of places will. Some of these properties are remarkable just for the fact that they're worth many dollars per acre, so there'll be a big impact to some rich people there. This is a photo of Manhattan during the Storm Sandy. Storms are another important aspect of climate change, and I was living in the dark area in the middle there. That was quite an experience. One of the really difficult areas about climate change that we don't know very much about is the damage costs. So the IPCC report, for instance, that we just presented, does not really have too much on that. Although, well, you could say the whole of Working Group 2 is about the impacts, but typically not very much monetized. And why don't we monetize this? Why can't we say what the cost is going to be? Well, there's several reasons. One is that we don't exactly know what's going to happen, but we have risks. It's very clear that lots of people we put at risk, so there will be people who die. We don't know who, we don't know how many, but the risks increase. Now, risks are a little hard to evaluate. That's one problem. Another is that a lot of people who would be hurt and affected are low income. And so if some property gets lost in Bangladesh that is just worth $1 per hectare, is that less important than if Long Island is drowned outside New York, where a lot of rich people have their summer houses? Like, ethically, this becomes kind of difficult. But if land is drowned, people in economic calculations, they typically take the value of the land multiplied by the number of hectares lost, and they say that's the loss. Well, that's bad enough with land, right? But suppose, I mean, then we have lives lost as well. People who build roads all over the world, they calculate the cost of the road and then the time saved for the motorist, and then there are usually also some lives saved. Straighter roads have less accidents than curvy roads. And typically you kind of take the lifetime income of someone or some measure like that as the value of a statistical life. But that's a problem, because then the Bangladeshis who would be drowned would suddenly sort of seem to be less valuable than the Americans who were drowned. That's quite a severe ethical problem in that calculation. So, and then all this is happening in the future rather than now, so then we have the discounting. So we have discounting, we have ethical values, and then we have risks, and then we don't quite know what's going to happen anyway. So all this really makes it very difficult to say what the cost of damage is. But a few new good studies have started to be done. And Kyle Meng will come and give a lecture in the next course on this. And those of you who are here, and I know that's not everybody, will hear that, but there are studies, like the studies cited there, Horowitz and Dell, and then there's studies by Solomon Hsiang and Kyle Meng and others. About 10, 20 studies sort of showing what happens as it gets warmer. And one of the empirical variations they use is the fact that there's variations anyway from cold years to warm years, like due to the oscillations that are called El Niño, La Niña. And so some years, Zambia, say, is 1 or 2 degrees warmer than other years. And then using that kind of data, you can see, and they have shown that there are more conflicts, more wars, less growth, and a number of other bad things correlated with temperature. Why did it take such a long time to find this out, and why are there so few studies? Well, it turns out to be very difficult to do these studies. I just casually said that some years Zambia is 1 degree warmer. But like, if you really want a measure of that, like the data that are available are at a pixel level, like a square kilometer or something. And then maybe, a few measurements per hour, per day or something. You kind of have to construct an average temperature for Zambia in some intelligent way. And some countries have like 3/4 of the country is desert, and 1/4 is where people live. So maybe you don't want to take the average over the whole territory. Maybe you want the weighted average where people live. And then maybe the temperature difference in the day is more important than in the night, or something else. Right, so that just suggests it's really quite a tricky problem to construct that database. And so that's one of the things that these new people are doing is very careful data management and rather complicated econometrics. Yeah. Previously, this is a study by Solomon Hsiang, and I think Hsiang is a co-author of that one. Previously, people like Nordhaus have assumed that, the only sector that's going to be affected will be agriculture. But that's not true. It turns out that production in the cement industry is lower on warm years. And all kinds of sectors are affected. I don't think we really know quite why, but there could be lots of stress factors. Maybe the workers are more tired, don't work so well. Maybe the electricity supply is stressed, and there are more power outages and so on. Right? There could be a number of things going on. Yes, that's very true, and these guys have been writing and thinking a lot about that, and as a difficult problem. In some respects, as you suggested now, we can adapt, and the effect will be smaller if we have a trend and it gets warmer and warmer and warmer, rather than if we have variations. Adaptation would have the effect you said, but there could also be cumulative effects. Some things just get worse and worse, like effects on water supply, for instance. The more dry years you have, or warm years in a row, the lower the water table, and so there could be effects that are both cumulative and adaptable. So that's an area for research. This is seriously an area of research I recommend, particularly for those who it helps if you're good at statistics here. I mean, it's an area that requires good work. Yeah, same thing there. Now I'm going to show you a climate calculator. Have I showed you this before? Yes? Then I'll skip that. That's good. I got too much material. I put this. It's been a busy week, so I put this together rather quickly yesterday. What about this? Yes? Or no? This is one of my favorite slides. How do we deal with... the first version of this slide was one of these, plastic slides, and I did that a long time ago. Didn't I show this before? No? Okay. So, I think I can't remember. It was a conference in '92. How do you can you have growth in the economy and still take care of the environment? So I mean, you can adapt this to slightly different versions, but basically the question is, can we combine economic growth and care for the environment? This is really a big and epic question, right? Now here I take the example before 2020 or some number. So I did this a few years ago. Now we're getting really close to 2020. 50% is quite big. Maybe we should put 2030 there by now. But suppose we want to increase income by 50%, and we want to cut emissions by 50%. Is that possible? Sometimes I do this diagram also. I say, can we increase income by, say, 3% per year, and cut emissions by 2% per year? Because the conclusion of this calculator exercise here is, if we want to stay below 2 degrees, we basically have to start cutting emissions by 2% per year, starting now. And that's really difficult, and all countries have to do it. But now let's just think about the question: could we do this in the transport sector in the United States, for instance? Let's pretend we're in the United States. Can we have economic growth and still cut emissions by 2% per year in the transport sector? And then, well, so we have a formula for the demand for fuel. Yeah. So suppose the income elasticity is 1, and the price elasticity is 0.8. So then it's actually Q is equal to Y, P to the power minus 0.8. And I want this thing to go down by 2%. Income, we want that to go up, don't we? Say 3% per year. How do we solve that equation? Or you can do it for the totals up there. You want to increase, I mean, that would be per year. Or let's say we want to reduce this by 50%, we want to increase this by 50%. Can you solve that kind of problem? I think you wouldn't be in a PhD program in economics, or if you couldn't, right? That's not very difficult, because then P to the power minus 0.8 has to sort of equal 0.98 divided by 1.03, for instance. And so then P has to be this thing to the power of minus 1.25, or whatever. That's not really very difficult. So, yeah?
Because in reality, like, if a country, for instance, owns fuel, then that's part of the income, right?
That's a good point. So let's hold that thought. We will come back to it. So all you have to do is, well, for the 50% here, you just have to raise the fuel price by 300%. And the first time I presented that, I got lots of questions like, is that realistic? This is in 1992. So I said, well, is it realistic to let the atmosphere, get a carbon content that we don't know what will happen with the weather? And then people said, is it possible? You know what the answer to that is? Well, Europe has already done it. We have a price that is 3 or 4 times the US price. And the result is we use about 1/3 as much fuel. So this has already been tested. And that's not surprising, because that's where my elasticities come from, right? I mean, that's where the numbers come from. So this is a bunch of countries here. And here I just chose a few countries that, because if you take all the countries of the world, you get like spaghetti-looking diagrams. So I took 5 countries that are kind of important countries, and they kind of spread out nicely. So this is the United States. That's the nicest place to own a big car. And then Italy up at the top there, that's the most environmentally friendly country. When I say that, my Italian friends get very upset with me and they say, please, never say, not even as a joke, never say anything good about our governments. They didn't raise the price of gasoline because they wanted to help save the world. So why did they raise the price of gasoline in Italy? Maybe they couldn't tax anything else. Right? And poor Italians don't pay tax because they're poor. Rich Italians don't pay tax because they're rich. And so they have good lawyers and friends in the right place. Shops don't pay either. Gasoline is like it's inflammable and stuff, so it has to be controlled somehow, even in Italy. So maybe it was the only thing they could tax. Or whatever. I'm trying to be funny, right? Because I know it's Monday morning. But there are lots of reasons. One of the nice reasons is that the company, Fiat, the Italian car company, they like high gas taxes. You know why? Yeah, they make small cars. Otherwise, people would buy Mercedes. Yeah, well, so there's lots of reasons, whatever. They also have these really beautiful cities with very cute little streets where you can't drive a big car. And there's lots of reasons. But anyway, it's a fact. And then if you have high gasoline prices, then what is the effect? People use less gasoline. Here's Italy down here, per capita. This is a linear scale that goes down to 0 here. So this is not the kind of statistics diagram that is made to fool you, right? It's just a very straightforward diagram. Now, how much does it matter what the minister was thinking about? Maybe the environmental minister is corrupt and stupid. Does it make any difference? I think the tax has an effect irrespective of, people always throw this argument at me and say, oh, but that's not an environmental tax. That's a fiscal tax or a corrupt tax or whatever, stupid minister tax. I don't think it makes any difference. I think that at that level, economics works very well. If the price is high, people use less. So that consumption goes with that price. This consumption here goes with this price. And you can see when the price went up there, our consumption went down a bit. So that's where the elasticities come from. We put this into quite a simple statistical estimation model, and you get those elasticities. I heard there's a guy called Bashmakov. Everyone was talking about Bashmakov in Berlin. He has published an article where he says that the share of energy consumption, or maybe it was fuel, I don't know, I haven't seen the article, is constant. All countries, all ages. Obviously a bit of an exaggeration, but this was like referred to as Bashmakov's law. So what's the price elasticity there? It's another way of saying that the price elasticity is -1. Well, I have the elasticity as -0.8. Most people seem to think it's 0. People always talk about this and say, oh, fuel demand is very inelastic. Thing is, it's inelastic in the short run and elastic in the long run. So what also happens not every time, but sometimes when they raise the price of gasoline, a journalist will call me and say, so, what about your theories? has the demand gone down? And this like the same day as the price went up. And I said, well, no, the first year you get an effect of like minus 0.1, and in 15 years' time, the demand will be, with an elasticity of minus 0.8 or something, compared to what it would have been otherwise. And you never see that, because then other things happen. So the only way to see it is by doing statistics. It's time for a break.